Hi everyone, welcome to my class. Today we are going to talk again about science, and by the way, it's me, Mom Princess, and I'm going to guide you regarding our topic for today. We are about to discuss the net force, introduction, and calculation. So I hope that you are ready to listen with our topic for this day. There are two types of forces. If you're going to think about this tug of war, wherein we already know that forces has a unit of Newton or the standard unit of Newton. So we have here 300 Newton and another 300 Newton. If there is equal pull of forces on both sides, then each side is balanced and neither side will fall forward. Balanced forces are opposing forces of the same strength acting on an object. It results in no change in the motion of an object. Balanced forces do not cause a change in the motion of an object. So remember that. Okay? Next, there are balanced forces. There are also unbalanced forces. Unbalanced forces are opposing forces of the unequal strength acting on an object. It always causes a change in the motion of an object. Think about a game of tug of war. If there is an equal pull, then there are unbalanced forces and one side will fall forward. So, here we have 400 Newton going to the left and 300 Newton going to the right. Since there are greater forces here on the left side, which is 400 Newton, people on the right side with 300 Newton will fall forward on the side of 400 Newton, which is going to the left. So that is how unbalanced forces are being described. Now, let us have the definition of net force. Net force is the sum of all forces acting on an object. Still, the measured or the standard unit of force or net force is in newtons with the symbol of capital N or big N. It is also capable of accelerating a mass. Now, try to imagine this one. When net forces on each side are not equal, the objects or the object will move in the direction of the greater force. Look at this example of a seesaw. The force exerted by Matmat on the right is greater than the force exerted by Botchok on the left. If Matmat has 100 Newton and Botchok has 60 Newton, this is very obvious that the net force which has the greater amount is on the right side and the seesaw will move in the direction of the greater net force. So, since Botchok has only 60 Newton, he will move upward. And since Matmat has 100 Newton, he will move downward. So remember, when net forces on each side are not equal, the object moves in the direction of the greater force. So also, do not forget the following ideas. Equal forces are very obvious, they are balanced forces. Unequal forces are unbalanced forces. If the direction of the forces are in different direction, the operation that you're going to use is subtraction, meaning to say if forces will go to the left and the other one will go to the right, you need to subtract. If the direction of the forces is in the same direction, meaning to say both will go to the right, both will go to the left, you're going to add the forces. And another one, greater force wins. Okay? Greater force wins. So let us now have the calculation of the net force. This is actually very easy since the operations that you're going to use is either addition or subtraction. I have here a box wherein there are actually two forces involved in this box. We have here 20 Newton and we have here another 20 Newton. But if you're going to look at the arrowhead of the arrow here, you will notice that it is from the opposite direction. So the first question here is, before you calculate the net force, is the forces on this box, are the forces on this box unbalanced or balanced? 20 Newton and 20 Newton. So very obvious. The forces involved here is, so I'm going to make it again. I'm just going to remove this to make it clear. So the forces involved here is actually balance. Okay? So we have here balance forces. So next, since you will notice that from the arrow, it's going to the right and this arrow is going to the left. If the directions are not the same, the operation that you need to do is subtraction. So you need to subtract 20 Newton and minus, okay, minus 20 Newton. So, very elementary, 20 minus 20, 0. And the unit is Newton. So, therefore, the net force here, okay, net force is equal to 0 Newton. Okay, so you have here 0 Newton. And what direction? So since the direction, since the forces are equal or balanced, so the direction is stay in the position. So meaning to say that this box will not move. So our net force here is equivalent to 0 Newton. Next problem. Okay, so this box again, we have your 10 Newton and 27 Newton. And then take a look at the arrowhead, it is going to the right and this one is going to the left. Okay, so I'm going to erase this one. First question, are the forces balanced or unbalanced? Are they the same or they are not? So very obvious. These are what? And, okay, I'm going to repeat this one. Going to erase this. So these are what? Unbalanced forces. Okay. Next. So these are unbalanced forces. Okay. And then you will notice that the amount of forces given here are not the same. So what operation are you going to use? The first thing that you need to do, take a look at the arrow. Are the directions the same? Of course not. If the directions are not the same or they are having different directions, the operation that you need to use is subtraction. So we have here 27 Newton minus 10 Newton. So 27 minus 10 is equivalent to 17. And then just copy the unit of Newton. So your net force is equivalent to, or you can have it F of N, or net force is equivalent to 17 Newton. On what direction? So, remember, greater force wins. So, 27 Newton is going to the left and 10 Newton is going to the right. Since 27 is bigger than 10 Newton, so the direction of this net force is going to the left. Okay? So 17 Newton going to the left. Or you can have it, or you can write 17 Newton going, okay? Wait, I'm going to make it clear. I think my pen is a little bit lazy. Or I think my hand. Going to the left. Okay. So actually it's very hard to use this mouse in solving this problem. Next problem. Oh, take a look. There are already 3 forces involved in the box. So, first question, are the forces balanced or unbalanced? So, again, the answer is unbalanced. Okay? Wait, what's happening with my pen? It's not working well. Okay, so, unbalanced. Okay, unbalanced forces. Now, you will notice that there are actually the same forces here. So, you need to do these 2 forces that is acting in the same direction, and that is going downward or to the south. So, since these 2 forces are actually the same, so I told you a while ago that if it is same direction, you need to add. So you're just going to add 15 plus 15. What is 15 Newton plus 15 Newton? Okay, any idea? What is 15 plus 15? Oh, very obvious. The answer is what? 30 Newton. So 30 Newton going downward. Okay, so that's the answer for that first part. Now you already have here 28 Newton. So since these forces are unbalanced and they are not on the same direction, so you need to subtract. So 30 Newton that is going to the south or downward minus 28 Newton. So just put equals here. So 30 minus 28 is 2 Newton. And what direction? Is it upward or downward? Since downward is 30 Newton and greater than 28 Newton that is going upward, so the direction of the force is going downward. And the final answer here is 2 Newton going downward. See, it's just easy. Next. So, 18 Newton and 18 Newton. So, very obvious, this is what? Balance forces, right? So, very obvious also that they are in the same direction, and that is going up or going to the north. So, since they are having the same value of forces, so you need to to what? If they are on the same direction, add or subtract? Add. So 18 Newton plus 18 Newton is equivalent to 36 Newton. Therefore, your net force, your net force is equivalent to 36 Newton. Wait, my 3 is not good here. So I'm going to erase and do it again. So we have here 36 Newton. And what direction? Of course, going upward or to the north. So this is your net force. So see guys, it's just easy. If directions are the same, add. If directions are different, subtract. So, it seems that you really understand our discussion for this day. So let us have an activity. Let us check your understanding. Look at the box. So you have your 25 Newton and 39 Newton. First question, is these forces balanced or unbalanced? I will just write B for balance and U for unbalanced. So this is what? Balanced forces. Now, you need to calculate it already. So, you need to use what? Subtraction or addition. Take a look at the arrow. Direction of the arrow. Is it in the same direction? So, no. If not on the same direction, they are in different direction, you need to subtract. So, 39 Newton minus 25 Newton. 39 minus 25 is actually equivalent to 14. And you just need to copy Newton. So your net force or F net is equal to 14 Newton going to, take a look at the forces, greater forces wins. So it is what? 39. And the direction of 39 Newton is going to the left. So the final answer here is Fn or net force is equivalent to 14 Newton to the left. Next. See? You can have it. There are 3 forces involved here. So first question, you need to identify if that is balanced or unbalanced. So very obvious. The correct answer is what? Unbalanced. Right? So these are unbalanced forces. Okay, next. So since there are 2 forces that are the same, you need to add it first. So 8 Newton, wait, I'm going to erase it. So you have here 8 Newton. Since they are in the same direction, you need to add 8 Newton plus 8 Newton. I'm going to make it clear. 8 Newton is equivalent to what? 16 Newton. So after that, there are still forces below here, which is 25 Newton. Since they are unbalanced forces and they are not on the same direction, you need to subtract 25 Newton minus 16 Newton. And your F net or your net force is equivalent to 25 minus 16. That is what? 9 Newton. And what direction? So, on the upper part, which is 8 Newton plus 8 Newton, and that is 16 going downward, and 25 Newton is going upward. Since 25 is bigger than 16, therefore, the direction is going upward. So, the final answer is F net is equivalent to 9 Newton going up or upward. So guys, it seems that you really do your best in our discussion for this day. And based on your scores, you got it correctly. So very good. So this is the end of my discussion regarding net force and how are you going to calculate it. This is again Ma'am Princess Margaret Paz, your science teacher. Thank you.